For any assignment-related queries, call us at +1 678 648 4277. You can mail us at info@mathsassignmenthelp.com, info@mathsassignmenthelp.com, or reach us at https://www.mathsassignmenthelp.com. Problem 1. Complex arithmetic. A. Find the real and imaginary part of B. Solve via C. Find all possible values of D. Express cos for x in terms of cos x and sin x. E. When does equality hold in the triangle inequality? F. Draw a picture illustrating the polar coordinates of Z and answers. A, B, C. Same answer as part B. D. Euler. Mathsassignmenthelp.com. E. When Z1 and Z2 have the same argument, i.e. are on the same ray from the origin. F. Mathsassignmenthelp.com. Problem 2. Functions. A. Show that sin Z equals minus I sin is. Solution. B. Give the real and imaginary part of cos Z in terms of x and y using regular and hyperbolic sin and cos. Solution. We calculate this using exponentials. Alternatively, using the cosine addition formula. Mathsassignmenthelp.com. C. Is it true that? Solution. No. Here's a counterexample. Problem 3. Mappings. A. Show that the function maps the upper half plane to the unit disk. I. Show it maps the real axis to the unit circle. 2. Show it maps I to 0. 3. Conclude that the upper half plane is mapped to the unit disk. Solution. I. If Z is real, then so numerator and denominator have the same norm, i.e. the fraction has norm 1. QED, 2, clearly f, I equals 0. 3. The boundary of the half-plane is mapped to the boundary of the disk, and a point in the interior of the half-plane is mapped to the interior of the disk. This is enough to conclude that the image of the half-plane is inside the disk. Since it's easy to invert, it is easy to see that the map is in fact 1-to-1 and 1 minus onto the disk. Mathsassignmenthelp.com. B. Show that the function maps the unit circle to the line x equals minus 1 division / 2. Solution. We will learn good ways to manipulate expressions like this later in the course. Here we can do a direct calculation. Let be a point on the unit circle. Then, here we left the imaginary part uncomputed because the question is to show that the real part is minus 1 division / 2. Which we did. Problem 4. Analytic functions. A. Show that is analytic using the Cauchy-Riemann equations. Mathsassignmenthelp.com. Solution. Call the real and imaginary parts and respectively. Putting the partials in a matrix we have. We see that. Thus we have verified the Cauchy-Riemann equations. So, F(Z) is analytic. B. Show that is not analytic. Solution. Where u equals x and u equals minus y, taking partials. We see that. So the Cauchy-Riemann equations are not satisfied, and so f(Z) is not analytic. C. Give a region in the z-plane for which w equals z3 is a 1-to-1 map onto the entire w-plane. Mathsassignmenthelp.com. Solution. Since z3 triples arguments, we divide the plane into thirds and pick 1/3. We've chosen the shaded region in the figure below. The region includes the positive axis, but not the dashed line. D. Choose a branch of Z1 division /3 and a region of the plane where this branch is analytic. Do this so that the image under Z1 division /3 is contained in your region from part C. Solution: mathsassignmenthelp.com. We choose the branch of arc width. So, the plane has a branch cut along the non-negative real axis. Under W equals Z1 division /3, the image points all, as required by the problem. Problem 5. Line integrals, A. Compute, where C is the unit square. Solution: first note that as a function x means re z. We do the integral for each of the four sides separately. mathsassignmenthelp.com. Adding the together, the integral over the square is I. B. Compute, where C is the unit circle. mathsassignmenthelp.com. Solution: parameterize the circle, as usual, by. Since the integral is C. Compute, where C is the unit circle. Solution: since z cos z2 is entire, it is analytic on and inside the closed curve C. Therefore, by Cauchy's theorem, the integral is 0. D. Draw the is this region simply connected? Could you define a branch of log on this region? Solution: yes, the region is simply connected. Yes, you can define a branch of log on this region. To define a branch of log, you have to have a region where the argument is well defined and continuous. You can do this as long as the cut blocks any path that circles the origin. The figure below illustrates values of arg iz at a few points in the region. mathsassignmenthelp.com. E. Does. Here C is a simple closed curve. Solution: not always. We know f, z, equals ez is entire. So, if C goes around 0, then, by Cauchy's formula for derivatives. If C does not go around 0, then the integral is 0. F. Compute. mathsassignmenthelp.com. Solution: let and let I be the integral we want to compute. The trick is to integrate f over the closed contour shown, and then show that the contribution of to this integral vanishes as arc goes to infinity. The four singularities of the ones inside the contour are as usual. We break into two loops, one surrounding each singularity, and use Cauchy's formula to compute the integral over each loop separately. Factoring, we have mathsassignmenthelp.com. Summing, the integral around now will look at C1 and CR separately, parameterize. This goes to the we parameterize. mathsassignmenthelp.com. By the triangle inequality, if r greater than 1. Clearly this goes to 0 as r goes to infinity. Thus, the integral over the contour C1 plus CR goes to I as r gets large. But this integral always has square root the same value. We have shown that I equals. As a sanity check, we note that our answer is real and positive as it needs to be. Problem 6. Suppose f, z, is entire and f, z, 1 for all z. Show that f is a constant. Solution: since f, z, 1, we know f is never 0. Therefore 1 division /f, z, is entire and 1 division /f, z, 1. Being entire and bounded, it is constant by Liouville's theorem. Problem 7. Suppose f, z, is analytic and f is constant on the disk z minus z0, less than or equal to r. Show that f is constant on the disk. mathsassignmenthelp.com.